I like this a lot better. I don't have to run between two buildings to do this. So how's everybody doing? Staying sane, I hope? Yeah. Don't go crazy, folks. Just remember. Just think of it like as a societally imposed staycation. I know for me, like, it hasn't felt like much of a vacation so far as, you know, the whole room has been going mad, but, um, no, with respect to, room tours, I think I'll just leave my laptop on my desk, if that's okay with you guys. So, that's a good question. What is the policy if a student gets the virus? God forbid. Basically, unlimited MSAFs for the duration of the virus, and MSAF turns from, and this is actually a policy that's currently in place, MSAFs are no longer a 3-day extension. They are assignment exemption. So if anybody gets the coronavirus, of course, you know, you have to substantiate that that you actually do have the coronavirus. Like, that presumably would be something that you could substantiate, because in theory you should be tested. But anyway, I don't know how things are going to go. Anyway, with respect to that, basically you get unlimited MSAFs for the duration of your sickness with the virus. So try not to get it, but if you do, don't worry about it. We're going to get through this. So, with respect to the VPN, that is a sort of developing situation at the moment. I received word. Sorry, I'll stop playing with my headphones in just a moment. I received a communication from, you know, sort of high up in party sources, if you want to put it that way, that the VPN is a yeah, don't intentionally infect yourselves, okay? The VPN system at McMaster University was not designed with the type of load it's now experiencing in mind. As it turns out, there are only 750, they call them licenses, but essentially only 750 people can be logged on to the VPN simultaneously. This is, of course, inherently problematic because if the entirety of our class logged in to do their assignment simultaneously, we'd instantly blow out, a third of the university's entire, VPN infrastructure, which is, bad. So what I'm doing right now is I'm working with Eric on a alternative method of assignment distribution and submission. We're going to try to move away from Jupyter Hub, the Jupyter Hub submission system anyway. Is it possible to increase the quality of the video? It's currently 480. I don't know. I've been using the auto settings. It's probably not, but I can give it a try. I'm gonna have to stop the stream though for a couple of seconds. Give me. And we're back. Sorry about that, folks. No. Sorry. Yeah, that's a good question. How can we substantiate that we are infected if there aren't enough tests to go around? I'm going to have to be a little flexible. But I don't know, I might have to Skype you to hear your voice if it sounds like you have a cold or something. You understand why I can't just give free MSAFs out to everybody, just because they say so, right? Because that's very easy to abuse that sort of a system. So it's going to require some degree of substantiation. What that substantiation is, obviously the best substantiation of it would be some piece of paper that says you were tested and tested positive for the coronavirus. Failing that, some other method of substantiation will be required, but I'll be reasonably flexible as to what that is. Anyway, back to the VPN issue. Sorry, I can't do anything about the quality of the video. It's kind of an interesting... I know I just said VPN, but I'll talk about the quality of the video for just a few seconds. It's an interesting problem because, my laptop's graphics driver to the point where I can use driver or GPU accelerated encoding for the video. Using OBS, I have to use the software encoding for it, so that slows it down considerably and probably creates a quality problem with respect to the feed. I apologize for that. There's really nothing I can do about it at present, so I guess we're just going to have to make do. I have some questions. Will test 3 follow the same format as test 2? As in 3 questioned with a bonus question, or will it be different? Test 3 is not going to follow the same scheme as test 2, as it is now a take-home test. This is going to change things up considerably. It will be a Jupyter notebook, and it will be done via the VPN alternative methodology that I am about to describe. What are the anti-cheating measures in place for the tests given the take-home format? we're going to be using the same anti-cheating methods that we are currently employing on the assignments. That is to say, we're going to do checking with MOS. MOS is a good system. It is pretty reliable at finding the people who are cheating, so I've been happy with it so far. We're going to perhaps, do a little bit more rigorous human verification of people's submissions to verify that people aren't cheating. But, just don't cheat, okay? The solution to cheating is to just not cheat. So there you go. Anyway, getting back to the VPN issue. So the VPN is not on sort of going forward in the class. The VPN is not going to be a viable option for submission of the assignments. So this is what we're going to do. Probably. I'm going to be publishing new updated policy information sometime later today once the stream is finished, probably, with respect to the new procedures. But here is what I think is going to be the thing that happens at this point in time. We're going to take the workbooks on Jupyter Hub as they currently exist. We're going to make them available on Avenue so that you do not require VPN access to get at the assignment workbook. We are then going to require everybody to, well, require is a strong word. It is going to be highly recommended that students get their own local installation of Jupyter. So we're going to post instructions about how you can get a local installation of Jupyter. It's through the Anaconda Python distribution. There are going to be detailed instructions about how to load up the assignment notebooks through Anaconda and the Jupyter installation that comes in Anaconda. And then you basically fill out the assignment or the test in pretty much exactly the same manner as you have been used to up to this point, and then submit that notebook back to us through the assignment submission folders in Avenue, which haven't been set up yet, but they will be set up. With respect to all of that, the hidden test cases, the ones that are going to be used for the auto grading, will be then inserted into your Jupyter notebooks via this nifty script that Eric has, which will hopefully minimize the amount of interaction that people need to have with JHub2, the JHub2 server. In fact, it will be possible to completely download, complete, and submit your assignments, tests, and final exam without ever having to log into JHub2 via this mechanism. We'll still have to do it, but you guys won't, because we're still going to be using the server for the auto grading. But yeah, anyway, so information to follow. We're still hammering things out, but this is the type of situation in which this type of flexibility is exactly what is called for. So are there any questions with respect to that? And I'm going to wait a little bit for the latency to catch up to that so that I can actually see if you guys have any questions with respect to it. Okay. Actually, the latency doesn't seem to be too bad. So, if there are no further questions... Oh, actually, there's one other thing that I need to talk to you guys about with respect to the sort of housekeeping type things. Oh, could you please post resources for the class? What kinds of resources would you like? Are you talking about like a practice test? So with respect to the change in the delivery plan, there was this. Yeah. Okay. Yeah. So right now, with respect to the whole getting extra practice stuff, at the moment, I've got a full plate with respect to just getting things up and running. It's actually not too bad at the moment. Um, um, I'll get what I can get together when I can get it together. Hopefully, I'll be able to do it before the end of this. Great deal of my effort have to go into just get. Um, um, some of you may have noticed that a new announcement went up last evening with a so-called quote unquote official version of the change to the course policy with respect to everything moving online. This is based on a sort of form letter template that was distributed by my supervisor, the department chair, Dr. Mark Lawford, and it doesn't necessarily contain any changes to our existing policy, but it does make some things that had not yet been made explicitly clear, or things I hadn't set yet are now set within the confines of this document, so it's important to give it a read. In particular, the specific manner that we will go about the times. So, test number 3, it's a take-home test format, which means that you will have 24 hours on which during which the submissions will be due 9 a.m. on April 1st. Submissions will be made either through JHub2 or through Avenue. Either one is acceptable, but both have the same time restriction. That is to say, they have to be in by 9 o'clock April 1st. We will not be considering any submissions made after that point in time. Plus or minus like 10 seconds or something, something reasonable. The final is going to operate in very much the same way. It'll be, again, a take-home format. This one will be released at 9 a.m. on April 13th, which is the day on which our exam was going to be held anyway. That will be due for the submissions will need to be made by 9 a.m. on April 14th. Again, no late submissions will be accepted. And so that's how the final and the test are going to work. And I'm not going to be quite so generous with people who have all of these late submissions, given that the VPN has been causing most of the problem, and the VPN is going to no longer be a thing that you have to use. So, there you go. Sort of one final note about this particular document. It's been my understanding that the manner in which a lot of professors have, or maybe not even a lot of, not even perhaps a plurality, some professors may have been, I've heard that some professors are essentially axing their final exam and then redistributing their grades, sort of the weighting of the various assessments to recalculate the manner in which the grades are calculated. We are not going to be doing that. We are going to be continuing on as normal to the best of our ability. This means we are still having test 3. we are still having the final, and they are still worth the same amount as they were before. So with respect to that, essentially that's all of the information that I have at the moment with respect to all of that. So perhaps we can continue on with our lecture. However, I will ask at this point if there are any questions from the chat pertaining to any of the information that I have just divulged. And I'll give it a few moments to catch up to the lag. Okay. Good. So, when last we spoke, we were discussing this birthday calendar class example. This is a pretty good example of something I would consider to be, on the order of an easy class question on a test or something like that. At least, on tests as they existed before the great plague. So it's not a plague. Plagues are a lot more deadly. Anyway, so we did this birthday calendar example. You can see it's basically just a wrapper for a dictionary and a couple of functions associated with the dictionary. You like my green headphones? Well, thank you. They are Razer Krakens, I think. They're very old, but they have a mic. That's better than not having a mic, because the terrible thing about having using the mic that's like attached to your screen on your laptop is like anytime you type on your keyboard, it's like super loud in the microphone because of the vibration through the laptop itself. So whenever you're doing live streaming, it's really good to have an external mic. Anyway, so let's move on to our next example, a mean calculator. This task is to design a calculator for arithmetic mean with the following two operations: add n, which adds n to the collection, and mean, which returns the mean of the collection. So the mean should account for the same number being added multiple times. So with respect to the types of data structure, obviously this is going to require some sort of data structure. The types of data structures that we want, we're not going to want a set in this case, of course, because sets do not permit the user to use multiple things that are of the same value inside of set. So let's take a look at our, this is our example from last time. So let's make a new example and do this mean calculator. There we go. So, yeah, the latency isn't too bad actually at the moment. So, class. And please feel free to follow along if you're in a, technological position to be doing so. Class, mean calc. What are we inheriting from here? Object. We don't really have anything else that we're inheriting from. Every class needs a init, because that is where we're going to define the things that that's where we define the attributes of the class. So it's here that we are going to define what our data structure looks like. So we know we don't want to use a set. We know we don't want to use a dictionary because the key value, like there's really no purpose to a key value here. Like we don't have key and value as separate entities that we have to deal with. So it's really down to, do we want a tuple or a list? Tuples are, of course, immutable, and lists are mutable. So since this is a thing that we want to add to on a continuing basis, what we want here is a list rather than a tuple. So self dot collection, just call it dot call, is equal to an empty list. Fine, def. Now we want to define our next method. We've got two methods that we want to define, add n and mean. So define function or method add, taking self and n. Self, you know what, that's a stupid name, call like that. We'll just call it self.c, c for collection. So self.c equals, you can do something relatively simple like concatenation. Create a new list, put n inside the list, and then concatenate that on the end of C. You can also do this through an append operation. So that's that. Relatively simple. Now we need to define a method mean that calculates the mean. And please notice that while we are specified to, you know what, let me just, there, that's a bit better. While it specifies only one parameter here and no parameters there, always keep in mind that a method will always need to take self as a parameter, regardless of what other parameters it's asked you for. So, we can, well, how do you calculate a mean? The mean is just the sum of all of the elements inside of the collection divided by the number of elements in the collection. So, return, there's probably a built-in function for it, but return the sum of self.c divided by length of self.c. There we go. Relatively straightforward. Good. Incidentally, if you are working on a question for an assignment or a test or something, you don't have to add string or, like in the birthday example, we see that there are like a couple of functions that are not required, not asked for, which are included anyway. Well, most particularly string. That you don't have to do it if it doesn't ask for it when you're doing a test or an assignment question. Okay, I have a question from LeBron James, I'm sure. Can you see problems arising if we take the Jupyter Hub assignment home and it works but on our own Python environment but not on the Python environment, possibly because of dependencies? Shouldn't be a problem. Because if you're using, well, I suppose if you're using library files that are not sort of included by default in the Jupyter Hub installation, then you might run into problems, yes. Like if you're trying to import some fancy abstract library for this, that, or the other. I don't know. You know what? I don't know, but Eric would. Would you mind taking that question and shooting it to Eric? Because he would have a better idea of like what the libraries that are installed by default in Jupyter in JHub2 are. I'm pretty sure that anything that's in Anaconda should be in there as well, but it would be a good thing to check, yes. Generally speaking, for like all of your file I/O stuff, like import CSV or JSON or stuff like that, all of that's going to be all of that you won't have any problems with. But so in theory, yes, it is possible to write code on a local installation that wouldn't execute on JHub2. However, I don't think it's likely. But it's a good point. It's a good point to raise. So thanks. Thank you. So where were we? Ah, yes. So let's see how we did with in comparison to the version that is in the slides. Class mean calculator 1 computes. Yep. So we've got a doc string. We are initializing self.list. There we go. Self.list. Yeah, actually. Wow. That's pretty much the exact same thing, except with self.l instead of self.c. There we go. So, yeah. So that's how you write a class for a mean calculator. So, pursuant to that, here is a slightly more efficient version of the mean calculator. So I'm going to ask chat, why do you think that this one is more efficient than the last one? This is an experiment to see if interacting with the class via chat like that is a thing that's practical. Okay. Oh, does it take? Does the? Yes. Yes, it does. Thank you. All naive. Because it maintains the sum S and count C of the collection. Right. So, yeah, as your classmates have said, the reason that this is a more efficient solution is because it occupies a significantly fewer memory, a lot less memory, rather than maintaining this giant honking list, as you say, of every individual, basically keeping a history of all of the things that have been put into the collection. The only thing that we actually need from the collection is the sum of that collection, so and the number of things in the collection, so we can keep track of that as we add things to the collection. And then at the end, we don't have to make reference to a sum operation or a calculating the length of the thing either. And incidentally, this also saves us runtime, because ordinarily the sum operation, the sum function, that will have a runtime that is linearly proportional to the size of the collection. However, you're also to add n elements to the list is also proportional to the that's linearly proportional to the number of add operations, which is the number of things in the list. So you're essentially dividing your runtime in half by not having to recalculate the sum. That being said, one of the ways in which what you gain in efficiency, you lose in adaptability. So if you wanted to, at a later point in time, adapt this mean calculator to be able to calculate more than just the mean, for example, if you want to be able to calculate the mode of a data set, or calculate the standard deviation of the data set, or any of these, sort of nominal statistical operations. These are all things that you would lose the ability to do because you're no longer keeping that information. You're only keeping the sum and the number of elements, not the actual elements. So not a good suggestion for linear regression, but if all you need is a mean, then this could be efficient. So here is a question. Please enter your responses into the chat. If only add and mean are used, can mean calculator 1 and 2 be distinguished? And what it means by can they be distinguished is, from a black box perspective, would there be any difference whatsoever between mean calculator 1 and mean calculator 2? So if you used mean calculator 1 and 2, you called the same methods in the same order, and then would there be any difference in the output? Enter your responses now! So the answer is, in fact, B. No. There would be no way to distinguish between these two classes. This is a good example of what we call black box design. It doesn't matter from the perspective of, the use of the function, the manner in which its implementation details have been performed. All that matters is how it behaves externally. Yes, okay, all right, yeah. So in terms of how fast they run and how much memory they use, they can be distinguished. But from a black box perspective, they cannot be. Yeah. Well, I mean, yeah, okay. Okay, LeBron James. Sure. Anyway. So, functions provide functional or algorithmic abstraction. Functions can be used without the need to know the algorithm they implement. The function documentation specifies declaratively what a function computes. So the documentation, as we've discussed in class previously, good documentation tells you what the inputs are and what the outputs are, right? So, and it tells you what the relationship between the inputs and the outputs are. This allows you to abstract away all of the implementation details. You don't need to know how the function computes it. You don't need to know how the math library computes sine. All that you need to know is that, if you put pi in, you'll get 1. Or is it 1? I think that's... No, that would be 0. Anyway, so the difference with a class is that classes provide what's called data abstraction. Classes can be used without needing to know the data structures of the implementation. The documentation refers to abstract data structures that may not actually be present in the implementation. So with respect to the previous example, the difference between mean calculator and 1 and 2 with respect to input and output and the documentation thereof and the relationship there between, that doesn't necessarily, it can have the same documentation because we're abstracting away this sort of idea of how the data is being stored. As I said, how you store the data may have a significant impact on the manner in which that class may be modified and changed in the future and functionality added to it, or that type of thing. But with respect to the simple use of the class, it is sort of an external concern. So we're now we're going to introduce another idea here. One of the things that is a very important concern with respect to global variables and local variables and whether or not a global variable can be accessed inside of a function and this sort of thing. This all has an analogy inside of classes, and this is so important a thing that some languages will require you to declare upfront whether or not your thing that you're defining for a class, like the attribute that you're defining for a class, can be accessed outside of the class or not, normally via dot syntax. So we have this idea of private members. So in Python, you can make any attribute a private member of the class by putting a double underscore in front of it. The effect of making something private is that Python prevents any code that's outside of the class from accessing it. So it cannot be accessed via .syntax from outside of the class. However, it may still be accessed by methods within the class using self dot the attribute name. So this is good. This has many beneficial effects. Data privacy is one beneficial effect. It can have a much better data privacy policy if you're using private members. It also, to some extent, gives your it gives your methods purpose, if that makes sense. You might have the data structure that is containing data be private, but the means of accessing it is public. So, this private member can be accessed only in very specific ways. This is good because you want whoever's using your class to be making as few assumptions about the manner in which your data is being stored as possible. You can sort of imagine in the previous example, with respect to mean calculator, a user, if self.l is, in the case of mean calculator 1, if that is a public class, then the user can sort of define its method of... Sorry, let me back up a minute. If self.l is a public member, then it can be accessed by anybody who's just got hold of the instance of the mean calculator, the instantiated object. If they want to, they can access self.l through .syntax and perform any number of operations that they might want to do on it. This is problematic because as you'll find with many library functions, you don't necessarily know the manner in which the data is actually being stored. So you might be making assumptions about how the data is stored without, because you haven't read the documentation or whatever. This could lead to you writing code that has a problematic effect on the underlying data structure contained in the class. You might muck things up without realizing what you're doing. This is a problem. Especially if you are, for example, if you think you're dealing with mean calculator 1, but you're actually dealing with mean calculator 2. So what the existence of private members gives us, it gives us the ability to only allow access to the data structure through like pre-specified consistent means. So here's an example, our final mean calculator. This is an adaptation of mean calculator 2, which changes self.s and self.c into private members. So if we were to try to access, if we were to instantiate a mean calculator object and then try to access s or c from outside of that object, we would not be able to. I think we would probably, Python would raise an exception, like a permission-related exception. Yeah, so you can see basically the only difference here between this and mean calculator 2 is that each time, we'll get to that in a moment, folks. Each time S is accessed or C is accessed, we preface it with a double underscore. Yes, and that's as simple as it is. But it's important to understand like the permissions that are going on underneath the surface. So, if, for example, we took our birthday calendar class and we wanted to make calendar private, actually the simplest thing to do would be to do a find and replace operation. So replace self.calendar with self._calendar. There you go. All experienced programmers know that find and replace is like, you put it in the category of like essential tools. Find and replace to a programmer is kind of like the claw side of a hammer for a carpenter or something like that. So if you do that, then calendar becomes private and cannot be accessed outside of birthday calendar. So for example, if we wanted to perform some calculation like b dot calendar equals empty set or empty dictionary or something, like a manual clear operation, that would result in an error. So there you go. So we've got just a few slides left in our discussion of classes, but I'd like to take this opportunity to see if anybody in the class has any questions about the things that we talked about today. If anybody has any questions about private versus public members or anything like that. Usually the questions I've been having are pretty good. Wouldn't inputs be different? Input would be some. Oh, that's a reply as applied to. Sorry, I missed your question. Wouldn't the inputs be different though? The input would be a sum for one n rather than a list. So with respect to the mean calculator example, the way that you're putting stuff in the list is not like the way that you put stuff in the list and the way that you put stuff in the the running sum is precisely the same. The interface is exactly the same because the interface is the parameters which are defined by the method. So in the case of mean calculator 1, we've got self and some integer n, and in the case of mean calculator 2, we've got self and some integer n. From the perspective of anything calling add, these are precisely the same situation. Yeah, okay. So it seems that we do not have any other questions. So we will continue on in 2 days' time. In the meantime, stay frosty. Don't go to shopping malls if you can avoid it. Yeah, just avoid people generally. Oh, there was something I heard about the virus. Yes, apparently the U.S. is starting trials for a vaccine now. I saw that in my news feed, which hopefully that works out. Good luck to all of those brilliant men and women working on finding a solution to this problem for us. But other than that, thank you very much, folks. I'll stay on stream for a few more minutes to answer any questions that anybody might have. But other than that, take her easy, folks. Don't go insane. Yeah, I actually really like the live stream format. Like, this would be a great thing for like if I was like feeling under the weather and like it would be a better sort of situation for me to do it from my computer. This seems like it would be a reasonable way to go about it. But yeah, this is cool. I like live streaming. Oh, and happy St. Patrick's Day. That's what the background is about. Yeah, I mean, like, with respect to live streaming, I would love to have like the resources available to have the sort of when I'm running regular lectures. I think it would be a cool thing to also have those going up on live stream. It would sort of require like I'd need a TA or something to be like running the live stream while the lecture was going on. But yeah, I don't know. Lots of thinking going on. Oh my god, that screen, yes. Well, we don't ever have to deal with that screen, that projector ever again, folks. Okay, well, looks like there aren't any questions, so I'm going to sign off here. Take her easy, folks.